Okay, so this is the key to test one, number one, and these are multiple choice questions for the first part. But it says, which of the following represents the y-intercept of the following linear equation? And so the linear equation is 3x minus 5y equals 30. And you have your set of ordered pairs that are possible choices. And remember, the y-intercept is where the graph crosses the y-axis. So this would be a y-intercept. Now, whenever the graph crosses the y-axis, the y-intercept, the x-coordinate is 0. All right, so if you want to find the y-intercept for this equation, you're going to let x equal 0, because no matter where you are on the y-axis, the x-coordinate is 0. So obviously it's going to be one of these two choices. It won't be C or D. So you could eliminate C and D in this particular case, since these are multiple choice items. So to find the y-intercept, where we see the variable x, you can let that be 0. So I get 3 times 0 minus 5y equal 30. 3 times 0 is 0. 0 minus 5y is a negative 5y equal 30. And then if I just go ahead and solve for y, divide both sides by the coefficient, which is negative 5. Negative 5 divided by negative 5 is 1. 1 times y is y, so my y-intercept is going to be negative 6. So as an ordered pair, your y-intercept is 0, negative 6, so the choice is B. And number 2, you're given this finite set of ordered pairs, so you have this relation. And this relation has 1, 2, 3, 4, 5 elements in it, five ordered sets of ordered pairs. And you want to find the domain and range. Well, you got to remember that the domain is the set of x coordinates, and the range is a set of y coordinates. And so if you look at your x coordinates, you have negative 2, 4, negative 6, negative 8, 7. So that will be your domain. And then the range would be the set of y coordinates, 3, 0, negative 1, 2, and 0. And remember, you only list it once. So let's see which one it will be. It will be, in this case, A. All right, number 3, you want to find the GCF, the greatest common factor of the following three terms. And so your terms are 4x squared y cubed, 8x cubed y, and then 16x to the fourth. All right, so let's go ahead and find the GCF of the constants, of the coefficients first. So the GCF of 4, 8, and 16. So the GCF of 4, 8, and 16 is 4. That's the greatest common factor. That's the largest factor that they have in common. 4 goes into 4, 4 goes into 8, and 4 goes into 16. So we can eliminate, in this case, we can eliminate C and D in this particular case. Because the coefficient here is 2, the coefficient here is 2. So it's either going to be A, B, or E. All right, now let's talk about the variables. So far my GCF is 4 times some expression. Okay, so if I look at the variable x, there are 2 factors of x here, there are 3 factors of x here, and there are 4 factors of x here. So the largest common factor that they have in common in terms of the variable x is 2. So they have 2 here, there's 3 here, there's 4 factors here, so you're going to need x squared. All right, so right away I can eliminate that one because that's x to the fourth. So then I go to the variable y. There are 3 factors of y here, 1 factor of y here, and there are no factors here. So they have no y. All these 3 terms don't have y as a common factor. So that's your answer. So it'll be letter E. Okay, number 4, it says this. Susan is in the process of factoring the following polynomial. She first needs to determine the GCF of the polynomial. Now notice that this polynomial has 3 terms. What is the GCF of the polynomial? Well, if you look at 6x squared, the term 6x squared, the term 3x, and the term 3, that is very similar to what you had to do here. And so the GCF of these 3 terms, there's no x as a common factor in all 3. But if I look at the coefficient 6, the coefficient 3, and the constant 3, the GCF of those 3 terms is 3. So the answer should be B, 3. Okay, number 2, fill in the blank with the indicated words. All right, so number 5, you want to determine if each of the following relations is a function. So remember, a relation is a function if for each x coordinate there's exactly one y coordinate attached to it. So for each x, there's one y. So write yes or no. All right, so we have this relation. It's a finite relation. So I'm going to go ahead and use a mapping. So here's x, here's y. And so when x is negative 2, the y value is 3. When x is 2, the y value is 1. When x is negative 4, the y value is negative 3. And when x is 2, now remember I already have it listed, so you don't list it again. So when x is 2, the y value is 8. And right away I can stop because when x is 2, there is two different y values. The definition says for each x coordinate it's got to be just one. So when x is 2, there's 1, and when x is 2, there's also 8. So that's not a function. All right, letter B. Let's go ahead and do the mapping again. So we have, this will be B. Okay, so when x is 5, my y value is 3. When x is 7, my y value is 1. When x is negative 4, my y value is negative 3. And when x is 2, my y value is 8. So notice that for each x coordinate, there's just one y coordinate associated with it. So this is a function. Letter C. Okay, so for letter C, for this relation, when x is 1, my y value is 5. When x is 7, my y value is 6. When x is negative 4, my y value is 5. I already have it 5 listed, so just list it once. And when x is 2, my y value is 8. So notice that for each x coordinate, there is just one y coordinate. It doesn't matter that two different x coordinates have the same y value. Just remember the definition of function says that for each x, there's got to be just one y, and there is. When x is 1, my y value is 5. When x is negative 4, my y value is 5. When x is 7, my y value is 6. When x is 2, my y value is 8. So that's a function. Okay, now in number 6, you have this linear equation, so you have this equation, and you want to state a solution to that equation. Well, remember, when you graph these lines, you're graphing solutions. So this linear equation has an infinite number of solutions. And so when you use the t-table, if you recall, when you use the t-table to graph this line, you are finding solutions to this line. You're graphing the solutions. And so all you had to do, there are an infinite number of possible answers here. All you had to do is just let x be some value and find out what y is. So if x is 0, I get y is negative 2 times 0 plus 5, which is 5. There's a possible answer that you could have given. If x is 1, I get y is negative 2 times 1, which is negative 2. Negative 2 plus 5 is 3. There's another one. So those are all possible answers to this item. So if x is negative 2, I get y is negative 2 times negative 2, which is 4. 4 plus 5 is 9. There's another solution. So there's an infinite number of solutions here. Okay, now in number 7, you're told that y is 7. All right, so remember when we graphed this, that was a horizontal line, y equals 7. And so remember that when we graphed that line, when we discussed this, that indicated that no matter what point you're looking at on this line, the y value is always 7. Y is always equal to 7, no matter what x is. So you could have picked any value for x here. So remember, these are all solutions, just same idea as with this one. So you could have said 0, 7, you could have said negative 1, 7, you could have said negative 2, 7, you could have said 3.57, and so on. So there are an infinite number of possible answers here. All right, number 8, you want to determine if the following relations represents a function, and write yes or no. So remember, the definition of a relation is that for each x coordinate, there's one y coordinate associated with it. And so when the graph is given a relation, we use, remember, the vertical line test to determine that. Vertical line test. And so no matter where I drew this vertical line, what that indicated was that for this x value, if I look at that point, there's only one point associated on that graph, and so there's just one y value. For this x coordinate, there's one y value. For this x coordinate, there's just one y value, whatever that y value is. So this passes a vertical line test. So this is a relation. I'm sorry, a function. Passes a vertical line test. Now over here, now this is sometimes a little bit difficult for students to understand. This is a vertical line. So if I look at this, all these all these x coordinates here is 3. So that's 3 something, 3 something, and so on. So notice that for this relation, for when x is 3, if I do this mapping again, there's only one x coordinate, there's only one element in my domain, and it's 3. So it gets mapped to an infinite number of possibilities. So 0, 2, -1, 3, and so on. So that's not a function. In fact, it fails a vertical line test, because if I draw this vertical line, it intersects the graph in more than one place. In fact, it intersects the graph in an infinite number of places. Letter C, if I do the vertical line test here, again, just like with this one, it passes the vertical line test. So for this x coordinate, there's just one y value. For this x coordinate, there's just one y value, whatever that y value may be. Over here, the circle, remember, for this x coordinate, there are two different y values. For this x coordinate, there are two different y values, so that's not a function. All right. Number 9. Okay, number 9, you're given this linear equation. So you want to solve this linear equation. All right, now a mistake people make is that they'll say 7 plus 2 is 9 and then distribute the 9. So remember, you got to use the order of operations. You got to multiply before you add. So you have to distribute first. So I get 7 plus 2 times 3 is 6x. 2 times -1 is a -2. And then minus x plus 5. And over here as well, so you distribute. So I get -3x minus 6. And -3 times +2 is a -6. And then plus 1. The next step is to combine like terms. So when I combine like terms, let's see, let's do the variables first. I get 6x and a -x is 5x. 7 minus 2 plus 5. So 7 subtract 2 is 5. 5 plus this 5 is 10. So on this expression here on the left side, I get 5x plus 10. On the right side, I get -3x, a -1, and a +1 is a -5. Okay. Now, we're going to bring all the variables one side, constants to the other. So I'm going to add 3x to both sides, because right now I'm subtracting. I have a -3x. And so when I combine, oops, sorry, that's adding. So when I combine like terms, I get 5x plus 3x is 8x plus 10 equal, these combine to give you 0, and 0 and -5 is a -5. Then finally, I'm going to subtract 10 from both sides. And then this is 0, so I get 8x when I combine like terms is equal to -15. And then, remember, I have 8x equal -15. So I got to get the variable x by itself. So right now the coefficient is 8, and I'm multiplying. The opposite multiplication is division. And so 8 divided by 8 is 1, because that's what I wanted. Remember, I wanted a coefficient of 1. 1 times x is x, equal -15/8. Okay, so that's your solution. Okay, now number 10, you want to factor the following polynomial by factoring out the GCF. Now, many students, they get the directions here confused. They think that all it's saying is just find the GCF. That's not what it's saying. It's saying factor. So first of all, you got to find the GCF. So the GCF of these three terms is, let's see, the coefficients are 2, -4, and 4. So the GCF of that would be 2. I have x's as factors in all of them. So there are 2 here, 3 here, 2 here. So I'm going to use 2. And then there are y's as factors in all of them. There's 1 here, 2 here, 2 here. So I need 1. And so there are 2 GCFs. So you're going to say GCF, which is 2x squared y, times 3 terms, because you have 3 terms here. So you got to factor. Just don't find the GCF. You got to factor this right here. So 2x squared y times 1 is 2x squared y, minus 2 times 2 is 4, so I need a 2 here. I'm factoring out two factors of x. There are 3 here, so I need 1. And remember, always check. X squared times x is x cubed. And then I'm factoring out 1 factor y here. There are 2 here, so I need 1 here. And always check. Y times y is y squared. Plus, all right, 2 times 2 is 4. I'm factoring out 2 factors of x. That's what I had originally. So I'm not going to write anything here right now. And then I'm factoring out 1 factor y. There are 2 here, so I need 1. And always check. So let's check the last one. So I have 2x squared y times 2y. 2 times 2 is 4. X squared. Y times y is y squared. And that's what this was. All right, so there's your answer for that one. Same thing here. Now, here, you got to think of this as 2 groups right here. So these are your 2 groups. Now, if I look at these 2 groups, the GCF of these 2 groups is 2x plus 1. So I'm going to factor out 2x minus 1. Factor out 2x minus 1. When I factor out 2x minus 1, remember that's your GCF. That's your GCF. So the GCF here is 2x minus 1. So when I factor out the 2x minus 1, there are 2 groups we said, so you better have 2 terms in here. So when I factor out the 2x minus 1, I get 5x as my first term. Factor out the 2x minus 1, I have minus 3 as the other. All right, so I get in parentheses 2x minus 1 times 5x minus 3. All right, number 12. Again, you want to factor out the polynomial by factoring out the GCF. And so, if I look at those 3 terms, I have 15, negative 10, and 5. So the GCF is 5 so far. I have factors of x in all of them. There are 4 here, 3 here, 2 here, so I'm going to need 2 of them. So that's your GCF, 5x squared. So I get 5x squared times a polynomial that would give me this back. So there are 3 terms here. I need 3 terms here. So 5x squared times 3x squared. 5 times 3 is 15. X squared times x squared is x to the 4th. So I'm factoring out 2 factors of x over 4, so I need 2 here. Minus 5 times 2 is 10. I'm factoring out 2 factors of x. There are 3 here, so I need 1 here. And then plus, and then 5 times 1, just leave the 1 off for right now. And then I'm factoring out 2 factors of x. That was 2 here. So what I need here is actually 1, because 5x squared times 1 is 5x squared. So that's the answer there. Here you want to find the GCF of those 3 terms. So if you look at the coefficients are all 1s, so we don't have to deal with that right now. There are factors of a in all of them. There are 3 here, 2 here, 4 here, so I need 2 of them. There are factors of b in all of them. So 4 factors here, 5 factors here, 5 factors here, so I need 4 factors. So there's your GCF. In number 14, you want to graph this linear equation, and we're going to use a t-table. So it's always a good idea whenever y is by itself to let x be 0. So if x is 0, you get y equals 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is a negative 1. So I'll plot the point 0, negative 1, which is here. So that happens to be the y-intercept. When x is, let's say, and just you can use any number you want to, any decimal, any fraction, but I wouldn't use those. I would use nice numbers that would give me, for the values of y, I would use integers for x, so that way I can get integers for y. So if x is 2, I get y equals 2 times 2, where we see the variable x, you substitute 2 minus 1, so that's 4 minus 1, which is 3. So I'll plot the point 2, 3. If x is, let's say, negative 1, I get y equals 2 times negative 1 minus 1. So that's negative 2 minus 1, which is negative 3. So I get negative 1, negative 3, which is here. And then all you do now is just use your ruler, use a straight edge to graph this line. And don't forget your arrows. Don't forget these arrows. All right, now, so there could have been an infinite number of possibilities here, as long as it fit within this grid. Okay, number 15. So 15, you'll notice that the coefficient of x is a fraction. So when doing this by t-table, you want to use values of x that are divisible by 4. That makes things a lot easier for you. That will allow you, in this particular case, to have integers for both columns. So again, let x be 0. So I get y equals negative 3/4 times 0 plus 2. Negative 3/4 times 0, 0. 0 plus 2 is 2. So I plot the point 0, 2, which is here. And if x is 4, so again, 4 is divisible by 4. Use numbers divisible by 4. So I get y equals negative 3/4 times 4 plus 2. Negative 3/4 times 4, the 4's divide out, so you get negative 3 plus 2, which is negative 1. So I'll plot the point for negative 1, which is here. And then let's just go ahead and let x be negative 4. So if x is negative 4, I get y equals negative 3/4 times negative 4 plus 2. Negative 3/4 times a negative 4 is a positive 3. And 3 plus 2 is 5. So plot the point negative 4, 5, which is here. Now, it did say in this case to go ahead and label. So we make sure we label. So it'll be 4, negative 1, 0, 2, and then this is 4, negative 4, 5. All right, and then you just go ahead and draw your line. Don't forget the arrows. So there's a line. And the same thing in the other one. I forgot to label the points here. I did say label. So this will be 2, 3, right here, 2, 3. This is 0, negative 1, and this is negative 1, negative 3. Okay, now 16, you want to graph this linear equation by using intercepts. So you got to remember that to find the x-intercept, you're going to let the y-coordinate be 0, and to find the y-intercept, you're going to let the x-coordinate equal 0. So let's go ahead and find the x-intercept first. So the x-intercept, I get 2x minus 3 times 0, because we're letting y equal 0, equal 12. 3 times 0 is 0, so I get 2x equal 12. So x-intercept, if I divide both sides by 2, is 6. So remember, it does say, though, write as an ordered pair. So I get 6, 0. So let's go ahead and plot this right here. So there's your your x-intercept, and label. All right, to find the y-intercept, you're going to let x be 0. So in place of x, you're going to substitute 0. So I get 2 times 0 minus 3y equal 12. 2 times 0 is 0, minus 3y is a negative 3y equal 12. So to get y by itself, I'm going to divide both sides by negative 3, the coefficient. And then when I divide, reduce, I get y-intercept is a negative 4. 12 divided by negative 3 is a negative 4. So as an ordered pair, that's going to be 0, negative 4. Remember, x is 0. So 0, negative 4. Here's your y-intercept. And then all you do now is just draw your line. All right, so it's important that you follow directions. So the directions here were to graph this using intercepts. Nothing else but intercepts. Okay, number 17. Okay, 17, you want to evaluate these functions at these values. So remember, f of 2 means what's the y coordinate, what's the y value when x is 2. So in place of x, I'm substitute 2. So I get f of 2 will be the absolute value of 2 minus 5 plus 3. Now, you got to remember, you're taking the absolute value, and so 2 minus 5 is a negative 3. So I have the absolute value of negative 3 plus 3. The absolute value of a negative 3 is 3. Not negative 3. The absolute value of negative 3 is 3, and 3 plus 3 is 6. Okay, f of 9. So in place of x, I'm substitute 9. So I get the absolute value of 9 minus 5 plus 3. The 9 minus 5 is 4, and so I have the absolute value of 4 plus 3. The absolute value of 4 is 4. 4 plus 3 is 7. Now f of negative 1. So I get the absolute value of negative 1 minus 5 plus 3. A negative 1 subtract 5 is a negative 6. So I get the absolute value negative 6 plus 3. The absolute value negative 6 is 6. 6 plus 3 is 9. So that goes here. All right, now here you're given this function g of x, and again you want to evaluate at these values for x's. So if x is, this says what's the y value when x is 1. So where we see the variable x, I substitute 1. So I get 3 times 1 squared minus 2 times 1. Well, you remember you got to do the order of operations. You got to square first before you multiply. 1 squared is 1. 1 times 3 is 3. And then 2 times 1 is 2. So I get 3 minus 2, which is 1. Over here, you have g of negative 2. So I get 3 times negative 2 squared minus 2 times negative 2. Order of operations, you got to square before you multiply. So negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 times 3 is 12. Now, a negative 2, think of this as adding up the opposite. So that's a negative 2 times negative 2 is a positive 4. So that's 16. Okay, number 9, you want to find the domain and range. Okay, so remember, domain is the set of x coordinates. The range is the set of y coordinates. Now, notice that in this case, you have an infinite number of ordered pairs here. So an infinite number of solutions on this relation. Same thing here. There are an infinite number of solutions here. So you have an infinite number of ordered pairs. So we're going to use the idea of an interval. We're going to use interval notation for these. So to find the domain, though, you go along the x-axis like this. And so when I start touching the graph right here, my x-coordinate, this right here, my x-coordinate right here, that's where I start touching right here, is negative 1. Now, since that is a point on the graph, I'm going to need a bracket. So I get bracket negative 1, comma, all the way to, and then my largest x-coordinate on the graph is 5. So that's your domain. For the range, you go along the y-axis. So I go like this. And so I start touching the graph here. So that's the smallest y value, which is negative 8. Smallest y value. Again, bracket negative 8, comma, all the way to negative 2. That's your largest y value. All right, now don't put parentheses. Parentheses would imply that these points are not solutions, and they are solutions. Okay, over here, domain. So you got to notice that this right here means it just keeps on going. All right, so here, to find the domain, you go along the x-axis. And so notice that if this was, let's say, negative 1 million, I'm going to get a point on the graph. So you're really going from negative infinity all the way to, and it never stops, positive infinity. All right, remember when you deal with infinity, negative infinity, you're always using parentheses, not brackets. Now the range, remember, is a set of y coordinates, so you go from smallest to largest. So when I go along the y-axis, I start touching the graph here. And so that smallest y value is this 1 right here. So I get bracket 1 all the way, and then it never stops. See, the arrows keep going up, so there's no maximum y value. So you're going to infinity with parentheses. Okay, number 20. All right, 20. So you're given this graph, and you want to find information from this graph. So here, you want to know what's the y value when x is 5. Well, here's where x is 5. Here's the point of the graph. So when x is 5, my y value is negative 2. So negative 2 goes here. Here, that's f of 9. So so when x is 9, what's the y value? So here's where x is 9. Here's the point of the graph. My y value is, so this is 9 comma 1. So my y value is 1. So 1 goes here. Now, some of you will put the ordered pair. That's incorrect. Don't put f of 9 is the ordered pair 9, 1. That's not true. They want to know what's the y value, so only put the y value here. F of negative 10, so usually that part will confuse students, but notice that f of negative 10 means what's the y value when x is negative 10. So x is negative 10, let's say around here. So there's negative 10. You want to know what's that y coordinate here. Well, remember, this is a horizontal line. And if you notice all these y values, they're the same. It's at positive 1. So this is negative 10, positive 1. And then letter D, what are the values of x for which, and remember, this means y is negative 1. F of x is y, so y is negative 1. Well, here's where y, see on your y-axis, here's negative 1. So if you look at points associated with it, there are actually 2 of them, here and here. So if I label those points, that's 3, negative 1. If I label that point, that's 6, negative 1. And the question is, what are the x coordinates, what are the x values associated with those points? Well, it's 3 and 6. 3 and 6. 21, you're given the graph again. Same idea. So you want to find, so there's my function g of x. So you want to find what's the y value when x is negative 2. So here's negative 2 in the x-axis. The point associated with it is here. So if I label that, that's negative 2, 4. So my y value is 4. What are the values of x for which the y value, remember g of x is y, so which y is 3? Well, I'm talking about the y-axis now, so look at y is 3, so that's this right here. So if I kind of do this, notice that there are 2 points on this graph associated with the y value of 3. So there's negative 3, 3, and then there's negative 1, 3. And so you're going to say negative 1 and negative 3 as your x values. Okay, what are the x intercepts? Remember, the x intercept is where the graph crosses or touches the x-axis. So it crosses 2 places. So here, which is negative 4, and then here, my x coordinate is 0. And you want to state the range of this relation, of this function in interval notation. So remember, we're dealing with range now. So you're going from along the y-axis. Notice that these arrows are going down, so there's no smallest y value. So you're going from negative infinity all the way, and then there is a largest y value, which is positive 4. So it'll be negative infinity to positive 4 with a bracket. And then finally 22. So 22, you're given that the graph of relation is shown below. So there's the graph, so it's a horizontal line. And you want to determine the equation of the line. So in the blank it says the equation of the line is, and you have to use one of these. Well, remember, x equal 5 means this. It means that the x coordinate is always 5 no matter what x is. So if I look at that, if I plot those points, I get 5, 0. I get 5, 1. That's a vertical line. That's not what this is. This is a horizontal line, so chances are it has to be this one. So let's look at it. If y is 5, that means that my y coordinate is always 5, no matter what x is. So if I look at that, if I plot those 2 points here, here's 0, 5 right here, and then here's, remember I want to plot 1, 5, here's 1, 5 right here, and so there it is. That's the one you need, y equals 5. Okay, so that's going to take care of the key to test 1.